So we're now going to be looking at the perfect square and the quadratic equations. So the first thing we would ask ourselves is, what is a perfect square? In quadratic equations, a perfect square is an expression that can be expressed as one bracket squared. For example, here we have a quadratic equation: ax squared plus bx plus c is equals to 0. This is a quadratic expression. Now, if any quadratic expression can be written as one bracket squared, like for example we have this squared, this is a perfect square. In terms of numbers, for example, if you have 9, you see 9 can be expressed as 3 squared, so 9 is a perfect square. Or 4 can be written as 2 squared. Let me say now, for example, 8 may not be a perfect square. Why? Because you see, for 8 we would need two different expressions. So even in quadratic, some quadratic expressions may be expressed as a product of two different expressions. So here we don't use equals, we use the equivalent sign. For example, we can have this another quadratic equation which can be expressed as maybe dx plus e and maybe ax plus b. So it can be expressed as a product of two expressions. This is not a perfect square. For a perfect square, it should be able to be expressed as a square of one expression. For example, how you see 9 can be expressed as 3 squared, or 4 can be expressed as 2 squared. But 8 cannot be a perfect square. Why? Because 8 cannot be expressed as a product of one expression, like as a square of one expression. You see, we have to get 2 and 4. Okay, now so this is what to say, that in any quadratic equation that can be expressed as this, like as the square of one single expression, is a perfect square. Okay, now let's look at an example. So we have this equation. Now I'm going to use factorization method. So what is A? A is 1, B is 6, and C is 9. So we said we have to find the sum B. Yeah, the sum B is 6. Then the product SC is 1 times 9. Then now we come and this is equals to 9. We get the factors of 9. So what are the factors of 9? We have 1 times 9, then we have 3 times 3. But we said we always have to also include the negative. So we have this, and negative 3 times negative 3. So what do? We have to get a number that when you multiply gives you 9, but when you add it gives you 6. So I think we see here it would be 3 and 3. Then now we put it in here. It's x squared plus 3x plus 3x plus 9 is equals to 0. Then you can factorize. You have x plus 3 into x plus 3 is equals to 0. So we have x plus 3 into x plus 3 is equals to 0. So you see, this expression can be written as x plus 3. So it can be written as x plus 3 squared. So it's a perfect square. You realize that if you find the answer will even be, it will have repeated roots. The roots will be x is equals to negative 3 and x is equals to negative 3. Then now for this one, if we are to try, we get the sum B is 5. Then the product SC will be 1 times 6, which will be 6. So we come and get the factors of 6. 1 times 6 and 2 times 3. But we said we always have to also include the negative factors. So this goes this. So we get which of these, when you multiply gives you 6, when you add gives you 5. We see it's 2, 3. So we come and say this is x squared plus 2x plus 3x plus is equals to 0. So we start factorizing. This is x plus 2, include this x plus 2, we have plus 3 is equals to 0. So now when you write this as a product of factors, it becomes this is equals to 0. So when you look at this, you realize it can't it's when you factorize, it's giving you two different expressions. It cannot be written as a product, as like a square of one expression, so it's not a perfect square. So now what's the application of this? We're going to see different numbers in which we apply the concept of a perfect square. Okay, so now let's look at a few examples. So this question says, find B if the quadratic expression this has a perfect square. So we said for any quadratic equation to have a perfect square, or to be said to have a perfect square, should be able to be expressed as the square of one expression. So let's start from here. X squared plus bx plus 12 should be equivalent. Notice not equal because these are different expression. D plus e squared. So now you can say consider dx plus e such that you expand it separately. So from our expansion, you can try to expand this from your own. You'll get this e x plus e squared. So this is what we have. So meaning x squared plus bx plus 12 is equivalent to d squared x squared plus 2dex plus e squared. So now we are going to compare coefficients, and I think I've said this before, that what are coefficients? Coefficients is the number just before a term. So we're going to start with x squared. So x squared, here x squared is 1, here x squared is d squared. So d squared is equals to 1. So d will be square root of 1. So what is d? D is 1. Then I go to the constant, comparing the coefficients of the constant. Here it's 12, here it's e squared. So e will be square root of 12. Then now I go to comparing x. Go to comparing x here, I will say 2de is equals to b. But what is d? D is 1. What is e? Root of 12. This is equals to b. So this is 2 root 12 is equals to b. So we found the value of b from this. Alright, so this is another example for us to try out. So the question wants us to find C if this quadratic has a perfect square. So the first thing we'll always do, we'll say we let this be equivalent to an expression like bx plus q squared. So what will this be? This will be the same as px plus q into px plus q. So eventually we would have this is px squared x squared plus 2pqx plus q squared. This is 2x squared plus 12x plus c is equals to that. Then now we go to comparing coefficients. Now we're going to compare our coefficients. So we'll start with x squared. So from the x squared, this is 2, this is p. So 2 is equals to p squared. So what is p? P is the root of 2. Then now we go to x. So comparing the coefficients of x, we have 2pq is equals to 12. So but p is root of 2. So we have this q is equals to 12. So now we can say what is q. Q will be 12 out of 2 root of 2. Then now we go to comparing constants. Here we have c will be q squared. So c will be q squared. But what was q? 12 out of 2 root of 2 squared. So what is c? C is going to be if you put this into our calculator, you're going to find that c is going to be 18. So you see now we've found the value of c.